Assalamualaikum, my name is Fahan Zaman, and today our group will explain about the Camelback Truss Bridge. First of all, I will introduce about the Camelback Truss Bridge. The Camelback Truss Bridge, with its distinctive curved design resembling a camel hump, emerged in the late 19th and early 20th centuries. It features triangle-shaped components including upright posts, flat chords, and slanted part, enhancing its strength against various forces. This design not only looks aesthetically pleasing but also ensures structural stability, making it a popular choice for both road and railroad bridge. The Camelback truss is best for bridge of medium size. It gives the right mix of strength and beauty. Special truss bridge called Camelback can be seen in many spots. They show how smart all engineers were. Many old Camelback truss bridges have been changed by newer design, but some still exist as landmarks. This made usefulness with pretty look from the past. The design shows a time when a beauty and strong building came together to make famous bridge that last forever. Now I will explain about background of case study. Camelback Bridge, iconic structure for 1800s, featured a unique one-arc design and played a crucial role in American railroad expansion. The innovative design often supplemented with trusses enables gaining longer distances and significantly impact transportation. Today, engineers use advanced techniques to ensure their safety. During their peak, Camelback Bridge faced challenges with materials and construction methods, prompting the use of wrought iron and steel. Maintenance is crucial for preserving this historical structure, and modern engineering ensures their longevity and adaptability to evolving travel needs. In summary, Camelback Bridge are historical and engineering marvels, combining aesthetic appeal with practical solutions that continue to influence transportation infrastructure.
My name is Muhammad Amirul Azmi bin Rosti, number metric AA230450. Will explain basic theory of the Camelback Truss Bridge. First of all, the Camelback Truss Bridge has an asymmetrical design resembling a hump, created by a curved top chord and a straight bottom chord modified from the Pratt truss. The curved top chord enhances structural stability, while the straight bottom chord provides a stable foundation, aiding in load distribution and support. Number 2, the good relationship between strength and material efficiency of truss bridge is attained by the Camelback truss design. In turn, the truss bridge have a stiff superstructure with interconnected members that usually from triangular units. These components, which are usually the straight ones, respond to dynamic loads by generating tension or compression or both. Truss bridges vary from basic design that can be dated back to the 19th and early 20th century. A truss bridge is economical to construct primarily because it uses materials efficiently. Camelback truss is a variation of the Parker truss that has a polygonal upper chord of exactly 5 slopes. This provides some saving of material with the greatest depth of truss where it is most required, at the center of the span. In addition, the State Highway Commission made only limited use of the type, and then only at long crossing used the Camelback variant as the center span of Nash County Bridge 271, erected over the Tar River just east of Spring Hops in 1921. We will go through for the real engineering application. As example, Deep River Camelback Truss Bridge. The Deep River Camelback Truss Bridge is a steel camelback truss resting on stone and concrete piers with a macadam road surface covering a plain deck. It spans the Deep River in North Carolina, United States, between the hamlet of Gulf in Chatham County and Camno in Lee County, in a quiet rural setting amid woods and farmland on both sides of the river. It was originally constructed in 1901. The bridge is listed on the National Register of Historic Places. The bridge is open to pedestrian traffic only. The design detail. Truss bridge #155 is a Camelback truss bridge, 160 feet long and divided into 8 panels, with the 2 trusses joined by a system of portal, lateral and sway braces. The truss system is spring joint. The trusses have the die punch eyes on the bottom chord, but also fork welded double cleavers on all tie bars. The bridge is supported by coldstone, north sides, and concrete piers with a macadam covered plank road surface. The remains of the earthen base and timber support for the Central piece of an earlier bridge may be seen below the bridge. That's all from me. Thank you.
We decide to construct the bridge based on Camelback truss design. The length of the bridge constructed in 90 cm, with edge of 20 cm and 10 cm for each knot of the truss. From the figure above, the dimension of the design bridge truss can be shown. Initially, we need to calculate the reaction force towards the bridge when the load is applied on the bridge. Using the concept equilibrium of force and moment, then we label each of the point alphabetically with A until R. From the calculation, we found that the reaction force towards the bridge support at point AY and JY is equal to 40 Newton. By using the equilibrium of force and moment theories and the equation from load of 80 Newton, eventually the simulation result shows same result between both of the support. Use a concept moment equal to 0 equal OP multiply with 0.2 minus 32 multiply with 0.3. OP equal to 9.6 divide 0.2, so OP equal to 40x Newton. Use force Y equal to 0 equal to negative 80 plus 32 plus FP sin 63.43. FP equal to 40x divided by 0.894. So FP 53.69 Newton. Use force X OP plus FG plus FP cos 63.43. 40x plus FG plus 53.69 cos 63.43. So FG equal to negative 72.02. Based on calculation, we derive the thrust force OP at 40x Newton tension, FP at 53.69 Newton tension, and FG at negative 72.02 Newton compression. Additionally, thus FG is exhibited at a tension force of 80 Newton, match the applied load.
Assalamualaikum, I'm Muhammad Aziz bin Syariah and my matrix number is AA230650. As I'm going to talk about the discussion, the chosen bridge design follows the Camelback truss and its planned dimensions are displayed in the figure above. To determine the force applied to the bridge under an 80 Newton load, we apply force and moment equilibrium principles. Points were labeled alphabetically and the resulting computations reveal that the reaction force at point AY and JY is 40 Newton. Trigonometric calculation estimate angles at 45 degree, 56 degree or 63 degree for each truss. Using these angles, along with specified measurements, which is 10 cm, 15 cm and 20 cm, we compute the truss height. A critical step involves sectioning the bridge at the load point to access force. At 0.3 meters from the support point, the truss experienced an 80 Newton load. Applying moment analysis and force equilibrium, we found that OF was at negative 62.43 Newton, which is compression, FP at 53.69 Newton, which is tension, and OP at 48 Newton, which is tension. Additionally, truss PG demonstrate a tension force of 80 Newton, matching the applied load. And now, I've been entrusted to talk about the conclusion of our study case. As conclusion, the design of the Camelback truss bridge has shown its strength and beauty in various distances. The Camel bridge truss is a type of truss bridge that has a polygonal upper chord with 5 slopes. The shape gives the bridge some advantages over other types of truss bridges, such as saving material, reducing the maximum stress and improving the stability of the bridge. The report successfully demonstrates the efficiency and durability of the Camelback truss configuration, showing adaptability to different environments. In this report, we use the load with 80 Newton to evaluate the data from the trusses. We use the formula to find the equilibrium and moment of the truss bridge. We apply the equation of static equilibrium to each joint in the truss. The equation are Fx, sum of Fx equals to 0, which is sum of force in x direction is 0, and sum of Fy is 0, which is sum of force in y direction is 0, and sum of moment equals to 0, which is sum of moment at any point is 0. This report highlights the relevance Camelback truss bridge in modern engineering and focus on their preservation and adaptation to develop a structure which is meet current standards while still maintaining its longevity.